Okay, we're going to take a complex number that's not in its trig form and raise it to a power. This is where De Moivre's theorem really comes in handy, because if you just work this in its standard form, you'd be taking this binomial, -1 plus I, and multiplying it by itself 12 times. And just to multiply it by itself once, -1 plus I times -1 plus I, you would either use the shortcut for squaring a binomial, or basically, this is FOIL. And it only works on a pair of binomials. So if you can imagine having to multiply 12 of them together, you'd have to do 2 and then take that answer times this one and then take that answer times, this would be very long. Okay, so De Moivre's theorem is going to be much easier. It's super easy, we saw, to raise a number in its trig form to a power. So here's the thing. We're going to have to take the number, which is currently in its standard form, and change it to its trig form, raise it to the power, and then change it back to standard form. Change the answer to standard form. Okay, so these are your basic 3 steps. You're going to take the original complex number and change it to trig form. You're going to then raise that to the requested power, and then you're going to take the answer that you got and change it back to standard form. So there are 3 major parts to these, but hopefully you can see this is easier than just working it with standard form. Okay, so if we take the number -1 plus I, that's our complex number. We'll remember the real part is -1 and the imaginary part is +1. Changing it to trig form, it is useful to picture it on the coordinate plane. So here's the ordered point, and we can draw in a reference triangle to help us visualize. So -1, that'll be the adjacent side, +1 would be here. There's our reference angle. Okay, so the tangent of the argument is 1 divided by -1, which is -1. Now, if you do the inverse tangent of that, that will give you a reference angle. It will not give you the actual answer. The inverse tangent of -1 in degrees is -45 degrees, and radians, -pi/4. You can see this point is in the second quadrant. These angles are not in the second quadrant. So -45 degrees, or -pi/4, is actually over here in the 4th quadrant. Okay, so the reference angle is 45 degrees. That's how much this angle is in here inside the triangle, 45 degrees. So our argument is going to be this much here. So 180 minus 45 degrees. Okay, or if you're doing radians, pi minus pi/4. Okay, so we end up with our argument being 135 degrees, or 3 pi/4 radians. And then here's how you figure out your r. Again, you can look at the triangle. -1 squared plus 1 squared will equal r squared. And r will work out to be the square root of 2. Okay, so all of this work is just taking the original complex number, -1 plus I, and putting it in its trig form. We haven't yet talked about raising it to the 12th power. Okay, so that would be the second major step. All right, so now I chose to work with the degree form. You can do, I'm sorry, the radians form. You can do degrees, it won't matter. This is just kind of an intermediate part of the problem. Okay, so to take the trig form and raise it to the 12th power, I'm going to be taking the modulus, square root of 2, and raising it to the 12th power. You could do this on the calculator because it does work out to be a nice number, but be careful. Sometimes the calculator might give you a decimal when there's actually a more exact value. So you could take the square root of 2 and write it as 2 to the 1/2. And that way you could work with the exponents and be a little more precise. So 1/2 times 12 gives you 6, and 2 to the 6 is where I got 64. All right, and then take the argument, the 3 pi/4, and multiply that by 12, and that would give you 9 pi, which is too large. We don't want to go over 2 pi. So if I find something coterminal, I could keep subtracting 2 pi from the 9 pi, and that will lead me eventually to pi. All right, so here is z raised to the 12th power, but this is in its trig form. All right, most of the time if the original question is given to you in standard form, they want the final answer in standard form. So that's why we have the third part of the question where we'll take that trig form and return it to standard form. So basically this is where you distribute the 64 and work out the trig values. So you're going to do 64 times the cosine of pi, which would be 64 times -1, and you'll get -64. That'll be the real part. And you'll do 64 times the sine of pi, which is 64 times 0. That gives you 0, so the imaginary part is actually 0. So you just end up with the answer of -64.